Welcome to our last Lunch and Learn of 2024. My name is Chris Carlton, and I am a wealth advisor at Truepoint. I also serve on our Healthy Aging Task Force. We created the task force to help our clients, team members, and their families with issues of aging by connecting with members of the community who can be helpful in this area. If you or a family member needs somebody to provide in-home care, help evaluate alternative living options, or is looking for a physical or occupational therapist that can come to your home, please reach out to us. These are just a few examples of the resources that we can provide. And if you have a referral to a person or organization who has been helpful in this area, please let us know. That's what led us to Dr. Schatz. So Dr. Rana Schatz is a UCNS certified behavioral neurologist and medical director of the Memory Disorders and Cognitive Cancer Clinics at the University of Cincinnati. I wore my red board. She holds the Bob and Sandy Hyman Chair in Alzheimer's Disease Research and Education and is a member of the National Cancer Institute CRCI Cognitive Science Network. For over 30 years, Dr. Schatz's passion has been the creation of brain wellness and flourishing, dementia prevention, and multidisciplinary systems for supporting individuals who experience cognitive impairment from cancer or neurodegenerative disease. Her current research centers on the role of sleep and inflammation in cancer-related cognitive impairment, the overlap of genetic and lifestyle factors common to these impairments in neurodegenerative disease, musical awe and enhancement of memory in cognitive disorders, and a learning healthcare systems approach to cancer-related cognitive impairment. Following a long-standing leadership and supportive role with the Alzheimer's Association, Dr. Schatz is partnering with them to create a support and educational system for patients with cancer-related cognitive impairment and their care partners. Please welcome Dr. Schatz.
Okay, do you hear me okay?
Yeah.
Okay, wonderful. Thank you so much for inviting me in. I know that a lot that I talked about today, probably of it is familiar in some way, and some of the presentation earlier has covered these topics. I want to kind of give you some conceptual frameworks and maybe different perspectives and understanding the information. And at the end, there'll be time for questions. But keep it in mind as we're going along. So first to start out, I did not start out in the world with any sort of science inclination at all. And really what I was interested in was literature. And way back in elementary grade, we had readers. And readers had a bunch of stories. But what was really interesting to me was at the end of the book, there were always characters. And to me, that was the most interesting thing. But it was in the back. And always kind of seemed a little magical for that reason, but also because these stories inevitably involved wars and wars. And we all know things happen. People tend to go into them. They tend to wander, get lost, bad things happen, but then they come out and they're better for it. Okay. So trees have been magical in my life from the very beginning. So fast forward, I'm here at Finnish Medical School and I'm practicing as a doctor, and along came this book, The Hidden Life of Trees. This is nonfiction, but lo and behold, it turns out trees indeed talk to one another. They support one another. They have systems of communication and even structures that are the same as inside of us. So, one of the things that got me very curious is there is a structure that is essential for memory called dendrite. It means little tree. And I wondered if there was something more than a superficial resemblance of trees to this structure in the brain, the dendrite. So I looked it up, and it turns out there's a mathematical model that underlies both the growth of trees and the growth of dendrites in the brain. So we're going to use trees and forests as our metaphors for our discussion today. So
Sorry.
You see if I can, oh, better, okay. I can work right and left here. Here we have exactly how the brain is put together. We have the trunk of the tree. It's a long pipe called an axon. It's actually a wire. And then at the end, it forms these nerve cells. Those axons are what we call, make up what we call white matter. Neurons are what make up gray matter. And then over a lifetime, what we're in the brain is in the business of doing is creating dendrites, these little trees, these ramifications that help connect and make a very complex communication system that is what wisdom is all about. So we're gonna kind of take another look at this system in another abstraction, and that is tinker toys. Okay. I never put together the word tinker meant thought. Okay. And then this is another way in which this is a great way of understanding what's going on in our brain. So if we look at those round blocks, those are nerve cells. Those are the neurons. And then the blue sticks are those axons that we talked about. And then these orange things are the dendrites. And what we're doing is growing a lot of those orange sticks over a lifetime. And what happens is not only do they connect with one another, but they connect in systems that we call networks. And networks are the basis of understanding how we accomplish thinking and how that thinking unravels in the neurodegenerative diseases. There are 3 main networks that we're going to focus on today. There are 5 of them kind of total, but 3 really important to understanding what happens in our brain. The first network is called the default network, and that's because most of the time, 60% of the time, we're in this mode. This is sort of daydreaming mode in a sense. But our brain is really active. It is has all the 5 senses active on the interpreting the environment and telling us what is going on. We need to know what is happening, and that happens through our senses. And not only does it pick up these signals, it makes sense of them. And when it is doing this work, it is also kind of giving us a awareness of what's going on. And that word where means it is a root for the word guard. So it's on guard, keeping us safe. In addition, not only does it pick up what's happening in the present, but it makes records of things for use later, a reference system. So events that happen to us are recorded into a book, essentially, an autobiography, the specific things that have happened to me. And it is created in chronologic order. And this is what's called episodic memory. Episodes in our life chronicled in this book as a result of our brain being aware of things and registering them. And that book is what makes our sense of self. So I describe this network as one that is related to senses, making sense of things and creating our sense of self. Now, if there's a network for taking in information, we have a network for action, doing things. And that's called the executive network, the know-how network. There is a type of memory associated with this network. This is holding information in mind while we're doing something, helps us keep track, know what steps to do, get feedback, have we done what we accomplished or not, and what do we need to do to make sure we are keeping track of that. It's a different kind of memory, and it goes away as soon as we're done doing something. And a lot of this network is also associated with coordinating the different actions that we need to take to accomplish tasks. Those are the cognitive aspects, kind of lining up what are the steps, and then the physical ones, connecting to the physical symptoms that move our muscles, coordinate movements, help us navigate the environment as we're doing these actions. And there is underlying this a emotion that helps us do these actions. This is motivation, okay? That root word, to move. So this network is involved in not only accomplishing things, but having the initiative to actually accomplish things, and spatial maps in which we can navigate our actions. And then finally, a network called the salience network. And this is, I call it the Miss Manners network, okay? Doing and saying things at the proper moment. Having the knowledge base in the place we live, the culture we live, to understand what's appropriate, what isn't appropriate, and also a lot of underpinnings of reflexive emotions that are responses to different nonverbal cues, threats in our environment. So it's the kind of emotion processing network. And each of these networks have importance for specific diseases. We'll get to that in a moment. Not only are there physical networks that are underlying thinking, there are chemical messenger systems. And these are important for understanding both medical treatments that we have, but also some of the things that we're going to talk about that can affect our brain over a lifetime. So there's a chemical neurotransmitter called acetylcholine, and the message it gives the network is receive, be aware, be alert. And this is the chemical associated with that default network, helps us process incoming information, be aware of it, and process it. Then we have the chemical adrenaline and its cousin dopamine. And these are two neurotransmitters that signal action. Get ready to do something. It underlies motivation. People know dopamine kind of helps with motivation. Adrenaline gets us energized. And it is also part of the fight or flight reflex illustrated there. And then there is the messenger system for emotions, serotonin. And this helps our subjective sense of what our feelings are, and objectively what are other people feeling. So when we look at a network, we go back to our tinker toy construction to understand a little bit about how it works. We have physical connections, and this is where we have at the point where a dendrite meets a neuron, a chemical messenger, those ones that we talked about, that give messages about how this next cell should respond. And then we have these sticks, these axons that connect these different parts of the network. And these are providing wiring. And just like wires in a wall, where you have the copper and then you have that beautifully colored plastic on the outside, our brains have those wires, but only white insulation, and the mass of it is what we call white matter, or myelin, and that helps conduct electrical impulses. And just like in an electrical grid, if you have loss of wires, you're going to have slowing. If you have loss of insulation, you're going to get short circuits, and you have more insulation, you'll be speedier, faster, and more efficient. So keep that in mind as we talk about how the brain works. Now, when the brain is forming, and we'll go back to our tree, it is growing these dendrites, okay? It's leafing out. And we just don't stay with that one initial connection. It is pruned and padded over a lifetime. That's what learning and experience are. It's the fine snipping of these connections. And we have both synapse growth, connective growth, and synapse destruction. And these are important over a lifetime to happen in the proper way so that we get the most precise information transmitted. We know that every time we learn something, there's actually an excess of connections created, almost 100 or 10,000 per nerve cell. And to make messages come off and help the system respond appropriately, we have to harmonize all of these connections in a way, and that's when this pruning process occurs. And we do create an excess of connections on purpose so that if we lose a few to disease, for example, or aging, we have an excess amount available to maintain function, even in the presence of things breaking us down. Now, how does that pruning process occur? A little aside for a moment, I have always loved gardens and maintaining them, and I get this subscription to something called English Gardens, gorgeous gardens, and it was my dream to take a gardening course in England. They always advertise them, and they're always in beautiful places. And so as a birthday present, my husband got me signed up for a gardening course in England. They speak English. Somewhat, okay. So I'm at the gardening course. We're about ready to go and collect some branches to make some supports. And the instructor, because everyone else was English, said, okay, now everybody, I want you to go in the shed. I want you to get some scissors, saws, and secateurs. And I said, secateurs. What are secateurs? And it took a while for that communication to come about. But I love that word. So when we're going to talk about the pruning process, we're going to talk about scissors, saws, and secateurs. And in the brain, this is accomplished through the immune system, a form of autoimmunity. Normally, when we think of that word, we think of it as a bad thing. We think of things like rheumatoid arthritis or lupus, but our brains use autoimmunity to do the pruning process. And this is a way we get rid of dead cells. We refine those connections. We know that even in utero, we begin to create these inflammatory cells called microglia that are specific to the brain. They're not found outside the brain. And that we're born with antibodies that didn't come from our mothers, but come from the brain creating them to start this process of pruning even before we're born. It begins that development of the structure that we're going to build upon over a lifetime. And over a lifetime, these inflammatory cells respond to learning. As soon as we start learning something, more of them appear, and they are doing their job of refining memory for us. So we want to keep on learning because it keeps the refining and support process and clearing of debris over a lifetime. The other thing we know is when we have neurodegenerative diseases like the dementias, we see these microglia change their activity to a negative. And this is something we're going to talk about. How does that come about? And maybe how can we prevent that from happening?
What was the second term?
A secretary.
Oh,
It's a
pruner.
yeah, it's a pruner. but it's got a special shape to it. So for the branches, it kind of curves around a little bit. This is just to show you graphically how the growth of synapses occurs early in life. We're increasing, but then once we get to about 4 years and beyond, we see actually a little bit of a decrease in the number of those connections. They're being refined as learning occurs, okay? And this is a picture of connectivity of the brain. So like those networks we talked about, on the left is a newborn. Everything's highly interconnected, okay? But we're not really very good at doing things when we're first born. And what helps underlie our ability to do things later is having these more precise connections. And you can see that illustrated. So we get to the fact that at some point in life, things seem to change for us. And there is one common theme that occurs to cause all the things that change thinking, and that's inflammation. And inflammation comes about because of normal changes that occur with aging. Our bodies are hardwired, the genes in our bodies change with age. Some turn on, some turn off, some disappear entirely. Then exposures, things that are like blood pressure, diabetes, high cholesterol. And then the fact that genetics for each of us is different. No two of us are the same. We come with a whole set of unique instructions in how our individual bodies work. And each of these factors are going to play a role in whether inflammation is going to work for us or against us. So here's how to think about keeping the brain healthy. We now know that almost half of the incidence of dementia can be prevented. And this comes about in considering several things. First of all, knowing that there are seeds planted that we had nothing to do with. That's our networks being developed in utero, highly related to the genetic influences on how networks are put together and what turns on and turns off during aging. And then there are additional factors relating to that pruning process, our own genetics that help with the normal inflammatory response and helping to regenerate after injury. Those seeds have been planted. But what do we have control over? Things that grow brain. And the things that grow brain, a lot of that has to do with very early exposures. We really have to invest in early childhood learning, even before the standard school years. Sleep, we'll talk about that in a bit. Exercise, a particular kind of eating pattern. We're going to talk about positive emotions and something called flourishing. The next thing we need to do is reduce the negatives, everything on this list, all the vascular factors, certain medication exposures, preventing our heads from getting bashed about, and improving our environment, our social environment and our physical environment. All these are now associated with neurodegenerative disease. These are things we can do something about. And this is what we're going to really kind of focus the rest of the discussion, okay? So I use the term neurodegeneration. What is neurodegeneration? It is the fact that we have systems in our brain that are interconnected. And what starts in a network is going to be propagated through that network. So that neurons that fire together, or wire together, fire together, tire together, and expire together. And it is networks failing that cause problems with thinking. And what we know is networks are extremely resilient. The idea of intercommunication, multiple centers, is that it provides for some redundancy. So if something goes wrong in one part of the network, another part of the network can pick up. And this means that we're going to continue functioning even if things are happening to our networks, and we won't know it, because we don't have glass to look inside our skulls. And we know decades before there's a first symptom that something's wrong with our brain, we're building up things that are bad. So amyloid protein, that's one of the things that, a form of it that causes inflammation. And then another protein called p-tau. And that certain genetics predispose this to happen earlier and more likely. We know that these changes are occurring while you have no clue. And actually, when there's the first clue, this is when the network is already broken down. So we can't use a measure of thinking ability, a score on a test, to tell us that our brains are healthy. Because by the time there's the earliest symptom, I'm not as sharp, things are slower for me, it's taking longer for me to do this, this means the network is already broken. It's no longer able to compensate. So we want to be looking at preventing this from happening. And I want to say, there's still out there the idea that as we get older, thinking declines. And this is not true. And I even read it in a couple of articles lately in the newspaper. This is a study of people 85 plus, followed till they died. And to ages, actually, I think 120 was the oldest person in this group. And what they found is that people can live through their hundreds with no cognitive impairment at all. And in that case, there were also in their brains no evidence of things like amyloid, vascular disease, Parkinson's changes, and so forth. And the people who declined with age had these different changes in their brain. So it's possible that our brains can keep our cognition functioning with age. So it is not true that we should expect changes in thinking with age. The other thing is there are many things that impact our brain. And even if we call something Alzheimer's disease, for example, we know that there's many other things going on in the brain. We're just beginning to understand how they all interact, but they all do. And the other thing is we now know what looks like Alzheimer's isn't always Alzheimer's disease. And that we have profiles, what the symptoms that a person has can be due to other things, something called TDP-43 or age-related tauopathy. So we want to be specific now in identifying what actually is going on to cause symptoms. We can't tell from the outside. Okay. Why is one person with the same things going on in their brain different in what happens to them? Well, first thing, networks are unique to us as fingerprints, okay? How we're put together. The machinery, the instruction manual, all of that is unique. So that makes each of us different. Aging changes us, and those aging genes and how they change in each of us is going to be unique and different as well. There are genes not only that break us down faster, they make us more regenerative and build back up faster. Some of us have good ones, some of us don't have as good ones. Chronic medical conditions impact us. What we choose to do with lifestyle, and then how much we build up over a lifetime these access connections that help us maintain function even if bad things happen to our brain. So all these things go into why each of us are going to be different, even if we all have the same things kind of on the surface going on. What we now think about in terms of how we want to approach our brain is not wait until we have symptoms. We want to look not at that point, even something called mild cognitive impairment is too late. Networks are broken down. We want to look way here, okay? Prevention. And so let's kind of take a little walk through prevention, all right? we talked about vascular factors. One of the easiest things that we can do is go to our doctors, know what our blood pressure is, and treat it if it's high. Know what our cholesterol is, and treat it if it's high, and keep both body weight and blood sugars in normal levels. Why is this? Well, the brain has its own immune system, as we talked about, and it is kept separate from the immune system in the rest of our body, because the immune cells in the rest of our body don't know what's normal inside our brains. And we don't want that access to occur. All these disorders break down that glass, that capsule that protects our brain and allows immune cells from the periphery to access the brain, and they do damage. So keeping these factors, which affect blood vessels and the barrier between the rest of our body and the brain intact, is what's going to help us prevent inflammatory changes that cause dementia. And I just want to say, there's often the case, people are diagnosed as vascular dementia. Vascular dementia is rare, but vascular disease is very common, and it breaks down this barrier and it makes neurodegeneration possible. And just going back to our metaphors of trees and networks, vascular disease mostly affects the white matter, those axons, those wiring systems. So what happens when you affect a wire in a grid? Well, you still have communication, but it might be slow or short-circuited, but it isn't absent. If you hit a node, like a nerve cell or a center of those nodes, you're going to knock it out, okay? So vascular disease, for the most part, is not affecting those nodes, it's affecting the wiring. It makes thinking slower, and it breaks down these barriers that cause neurodegenerative disease. So I just want to say it is not vascular dementia. If that's been given as a diagnosis, that's pretty rare. Okay. Diabetes. Diabetes is a sort of sapping energy from our brains. Why? Well, if the sugar is high in the blood, what it really means is it's not being transported to the brain. The brain runs on sugar. It's the biggest user of sugar. And if it's not getting enough, we're asking to run a machine in a less than efficient manner. And if that's long enough, things break down. Also, we know that it causes inflammation. And what we see happening, and in fact, I just saw someone this morning whose amyloid levels are going up in the brain, going down in the spinal fluid where we measure it, because her diabetes is out of control. And if that continues long enough, she's going to get Alzheimer's disease. So we want to control blood sugar because it supplies energy and it reduces the inflammation that can drive some of the changes that are going to cause Alzheimer's disease and other disorders. There's even a trial right now for intranasal insulin to prevent dementia. We don't have the results of that yet, but insulin helps transport sugar from the blood to the brain. And we think that even in people who don't have diabetes, maybe making that more efficient can help our brains. We talked about the fact that brains communicate with chemical signals, not just physical connections. And that one of those chemical signals is acetylcholine. That's the one that helps the network that has to do with senses making sense. This is the network most vulnerable to Alzheimer's disease. And drugs that have the property of lowering that chemical, lowering acetylcholine, called an anticholinergic activity, are going to, over a lifetime, increase the risk of Alzheimer's disease. We can measure the degree of which, to which drugs have this property of lowering acetylcholine, and it's called the anticholinergic burden. There is a way of calculating it online, and that's what I do with everybody who walks in the office. we know that even if you don't have dementia, if you take these drugs and your score is more than 4 total, that it decreases your performance on a common test that's used called mini mental state. We also know that taking drugs that have this activity over a lifetime is cumulative, increases the risk and stress on that network to make you more vulnerable to Alzheimer's. Some of these drugs are really powerful depressants of acetylcholine, and they're rated as a 3. If you have one drug that is that powerful, and you take it chronically over a lifetime, it increases your risk 3 times for having Alzheimer's disease.
What are the types of drugs?
Get you in a sec. Okay, good question. And those of us over 65 are at greatest risk, partly because of the way our genetics are, but also because many of the conditions that these drugs are used for are more common and people give these drugs out. So here they are. Anything that's called PM, diphenhydramine or Benadryl, muscle relaxants, and a lot of medications that are used for stress, hydroxyzine or Atarax, or for allergies, okay? Drugs that are used, benzodiazepines for stress. They're not designed for chronic use anyways, but the long-term use of these increase that risk. And medications for bladder control. The most common ones are Truepoint and Detrol, and these 2 are some of the worst. We have alternatives for all of these, so talk to your doctors if you're on them. And then the Z drugs for sleep. The only medication for sleep, first of all, you shouldn't need a medication, I'll get to that. But if you do take one, there's one called suvorexant or Belsomra. And that's the only one that doesn't have this property of increasing risk for Alzheimer's disease. And I'll kind of leave this one, but it turns out that unfortunately, a lot of the medicines that are given to people who already have cognitive impairment make this situation worse, because they're some of the drugs with the highest anticholinergic burden. And it's something to talk to your doctor about, because it undoes what we're trying to accomplish with treatment of those diseases. Now let's turn to sleep. Sleep is very complex. It's not just about the number of hours. It's the fact that you have 7 to 8 undisturbed hours, and you progress through different sleep stages. Each stage is unique in how it contributes to the processing of different kinds of information. So REM sleep, for example, is one that helps process new things that we learn how to do, physical things, procedures. For very complex things, we need combinations of different stages of sleep. So you get the idea. We need uninterrupted sleep so that we completely process information that we have put into memory during the day. And we can actually see what's happening during sleep in the stage called deep sleep, where memory is really fully consolidated. There are these, if you look at these sort of peaks on that sleep graph there, this is brain activity. And at the very top, you see a little ripple. These are 2 nerve cells talking to one another. And this back and forth is sort of saying, can you hear me? Can you hear me? It's the brain creating the new links between new connections, new dendrites. And that's what we want to happen without interruption. One thing that's important about sleep is not just the fact that it helps formation of memory, but it is essential for clearing toxins that build up during the day. When we make these links, these dendritic trees, we create some fragments of the construction protein called amyloid. And these fragments are very toxic. They cause inflammation. And after a day of all this memory work, We have this debris that has to be cleared, and this is done during deep sleep. If you look here, you see that channel? That's called a lymphatic, a glial lymphatic. It is a waste system in our brains. And this is where debris is discharged from a nerve cell. And it will travel through these rivulets and collect into this big reservoir called a ventricle in the middle of our brain. And from there, all the debris can be taken up by our blood and exit our bodies. During sleep, this process is enhanced. So when we're awake, that green is the amount of fluid flowing through these glial lymphatics. And if you look at sleep, see how much more? During this stage of sleep, it's almost like an ocean tide where these glial lymphatics dilate, more spinal fluid comes in, and it flushes away this debris. If we don't get to deep sleep because our sleep is interrupted, let's say by sleep apnea, very common, restless legs, the cat, there's a light, the TV is on, anything, we are going to miss out on reaching this stage of sleep, and we are going to have a brain that has too much garbage. So one of the most important things is if you don't sleep well, there's a reason why, and it can't be totally remedied by taking sleep medication. And if you're taking one, you gotta find out, why is this happening? Maybe you do have apnea. I will tell you, some of the people with the worst apnea had no clue. They didn't snore. Okay? So important. If you're not sleeping, go find out why. The other thing is we have to have good sleep habits. And our bodies evolved over millennia to help us survive. Being out of commission for 8 hours was a dangerous thing. So the body has a test of how safe is it to turn on the sleep system. One thing is that there's a place where we sleep. Okay, so sleep in bed. There's a certain number of hours, 8 hours, 7 to 8, no more, no less, because either side of that is poor quality sleep. On the same schedule each day, our bodies like clocks. That sleep clock will turn on for you much more efficiently if you always go to bed at the same time, and that wake clock will turn on if you always get up. And only sleep in bed. Our bodies are going to take stock of the activity around us. And if it's expected that we're going to do something else, it's going to want to keep those sensors on the environment on guard. And it means it's not going to put us fully asleep. So if you watch TV in bed, eat in bed, read in bed, work games in bed, you're not going to benefit, you're going to get the full benefit of sleep. So make the bed for sleep. And during the day, we don't want to sleep too much or we're going to confuse that clock. So keep naps to 20 minutes, no more. Alcohol, one of the worst things for sleep. I know it's relaxing, but it actually keeps sleep in a very light stage, much more likely to wake up. And in general, I'll just say this, I didn't get into it a whole lot, alcohol is not good for you. Okay, yeah.
So there's some reports about the temperature too.
Yes.
So that's also important. In fact, that actually plays very important role throughout the sleep.
Yeah, you're right. Temperature, cooler temperatures are better. It is, that's true. A little bit about food here. So I want to think about, talk about this issue of fat. Okay. Fat is an organ. We don't think of it that way, okay? But it is. And most of what it secretes, like all organs, does damage. It causes inflammation. The whole idea of the association of weight and fat to the risk for dementia comes from the fact that it causes inflammation inside our body. We want to lower fat for the purpose of lowering the inflammation that we generate inside of us from it. Now, when I first started out in medicine, this was the advice: eat nothing and laugh of it. That's not really true, okay? It's really important what we eat. And so we have a guideline, and you may have heard of this, called the MIND guideline for eating. It's a mashup of a couple different diets, Mediterranean and DASH diet. But what the researchers did to create this was pick the foods from each of these eating guidelines that had the highest anti-inflammatory activity. And the item that is most important is dark leafy greens. Kale, spinach, root greens. I saw some faces go like this. They're bitter. Okay? Well, something very interesting. The tasting of bitter starts a process in our body before that kale reaches our stomach to produce anti-inflammatory proteins. We need to taste bitter. However, if you add this every day, which is part of the MIND guideline, and mix it up with something else, it'll dilute it a little, so maybe you can tolerate it, but we still need to taste bitter. Okay, gotta eat it. Somebody asked me if they could just swallow a kale pill. I said no. So this MIND guideline has a list of items. We're gonna kind of walk through a couple of them in a moment, but there's 15 of them. Some of them you eat more of, some you eat less of. The idea is if you eat the prescribed portions of each through the week, you get a point for each of these 15 items, so a total of 15 possible. And what studies show us that if you are low, only score somewhere between 2 and 6.5 points, you're at high risk for Alzheimer's, 5 times the risk. If you score 7 to 8, your risk is reduced by 35%. And if you can get 9 or above, then you will have almost a 53% risk of Alzheimer's disease just by following this eating guideline. So this is a way of getting there. Besides eating that dark leafy green every day, adding another colored vegetable, a handful of beans, handful of seeds and nuts, berries, using olive oil as your dressing. You've got 1, 2, 3, 4, 5, 6 points. We need 3 more. Having fish once a week, poultry once a week or twice, and whole grains, 9 points. Easy to do. Salad, topped sometimes with fish or chicken, and some bread. If we do that every day, easy. We get to the MIND guidelines, okay? So think about choosing these foods. What's happening? Why is this happening? There was just research that showed us it changes our genetics. We can change bad genes into good genes. So people who met those MIND guidelines had increases in something called TCIM, a gene, that is associated with the growth of new nerve cells, the survival of nerves, more synapses, those connections, and maintaining and repairing that broken down blood-brain barrier. It also is associated with education. And it decreases genes that we know are associated with bad things, high blood pressure and short-term memory loss, just by eating good food. Well, you can't just eat, you gotta move. Aerobics are very important. It does many, many things. And we know that even now, the idea of daily activity as little as going for a walk for 15 or 20 minutes is effective. So please just go for that daily walk. And if you notice that footprint is in a bunch of trees, make that walk outdoors. We're going to talk about the outdoors in a moment. Partly, it's the experience of the activity being pleasurable. In fact, when exercise is done as part of work, it turns out that it's actually a negative. And that exercise done as a pleasure and an awareness of the environment in which we're doing it actually improves the benefit from that exercise. Part of what we're trying to do, as we said, is build this excess of connections in our brain so that if we lose them to some of these other conditions, we have others to take over. And this is called the building of cognitive reserve. And it is more than reducing all those stresses we talked about. It's how we build more connections through positive things. And this is where we're going to talk about what brain exercise really is. It is not computer games. It is not reading books. It is not doing Sudoku or crossword puzzles. What we're really trying to achieve is stimulating the human brain. The human brain is different than the animal brains in that humans have evolved to respond to differences, not patterns. Our brains wake up when we have something new in the environment. And I can pretty much tell you, you know this because when you walk into a room here, you kind of really notice who's new or what's new. That's our brains at work, doing the job. It can't pay attention to everything, so it pays attention to what's new. So if we turn that around, it means we constantly have to engage in new learning, novelty, and variety. And it gets harder when we leave work and retire because we have less of that opportunity. So we have to cultivate a lifestyle of learning. Also, it's really important that we emphasize the senses in our experiences. That's why working, exercise during work is not as effective as exercise in a forest, a walk in a beautiful environment. The senses are stimulated. That also feeds into that one brain network that Alzheimer's is vulnerable to, that sensory processing network. We need to give our brain lots of sensory information. So some of the things that are more portable than a walk outside are music. And I do research in musical awe is a portable form of helping to stimulate the senses, fragrances, beautiful vistas, artwork, creating anything that helps grow this brain. Being social, this we learned from COVID. Being isolated kills. Being isolated increased the Alzheimer's disease by astronomical numbers. So activities need to be not just by ourselves, with others. And then, oops, almost done. Cultivating particular emotions, okay? Emotions are really important. We tend to be focused on negative ones, at least physicians are. Things like depression and anxiety, they are important. They are like warning signs, dis-ease, disease is present. And we want to really take heed, not just that it's something that needs to be treated, but what else is going on in the body that's causing things, okay? That's the purpose of negative emotions, immediate problems that we have to pay attention to, alarm bells. Positive emotions are there for growing brain. All of the positive emotions help us with socialization, which increases cognitive reserve, as we talked about. But two emotions in particular I want to end on. These are awe and humor. These two emotions are associated with responses to the unexpected. And we said human brains are really tuned into what's new. Well, this is new on gasoline, okay? It is saying that when we have these emotions, our brains are saying, oh, okay, I'm really going to be changing my orientation to seeking and knowing more. Awe is really the sort of 180 of fear. If you think of the expression when you have fear, it's like, okay, what if you saw a beautiful sunset or an amazing, I know when I came over a ridge in the Grand Canyon and the sun was rising, it was like, oh, I did that, okay? It's the same facial expression. It's the same machinery. And what do we know about fear memory? Really hard to extinguish. That's what PTSD is. Well, what if we had a positive association with that? That's what awe does. It taps into this very resilient memory system, creates memories that don't break down. Okay? They are much more resistant. The more awe we have, the more we're creating the infrastructure in our brain for not just new memory, but memory that is going to withstand the ravages of what else happens to us. So we want to be paying attention when we are doing our activities, being mindful in the present, be aware of the environment. The outdoors is a very powerful producer of awe. And this is just the result of a study in which people took selfies before and after walks. And half the group was told, pay attention to the woods, the forests, the trees, the animals when you do your walk. And the others said, just do your walk. And what they found at the end of the study is the selfies changed. The smiles were bigger in people who paid attention to the world around them. So when we're looking at how do we keep our brain healthy, and I know I've taken too much time. Obviously. But there are things we can do, okay? Reduce the stress in our brain from those things that we talked about earlier and grow our brain. Follow that mind guideline. It's pretty easy. Taste that bitter. It's okay. Do the daily walks in the outdoors. Cultivate that sense of awe and new learning and be among others. And just being here today, you've already done just about everything on that list. Thank you so much for your attention. I'll start answering these. I know there were some from.
Have you done any research on these things? My grandchildren have them. Put them on your eye. You put them on your eye or your face. I forget what they call them.
Virtual reality.
Oh, virtual reality. Yeah.
And then you can be on the top of the Himalayas
Yes.
or, you know, you can be in different places. I've done it and it is kind of amazing. Is that the same thing as maybe taking a walk?
Yeah. I don't want to say you shouldn't be in the outdoors because there's other aspects of it. It's the fragrances, the movement, and the physical activity too. But we have been able to generate awe using virtual reality. For people who have disabilities, this has turned out to be a really helpful.
You said genetics is not. Oh, it's a
So
microphone.
the people on Zoom can hear you.
That is such an interesting. Yeah.
My father, sister, and brother all have, well, my father's gone, but my sister and brother currently have Alzheimer's.
Hmm.
And then I have another sister, we're the two youngest.
Okay.
Do you think it's important to find out if I have a genetic? I don't want to know, but should I find out?
Can you repeat the question?
Yeah, I'm going to.
I'm sorry.
Yeah, so the question was, there's a strong family history of Alzheimer's in 2 generations, but several older siblings. And what should you know? You should know that you are at risk. There's certain genes that we can identify that tell you, but you already know that, okay? So the key thing is at this moment in time, because the knowledge about which of those genes you have and which ones we can't measure that might still be contributing, all require the same approach, okay? And let me tell you one quick story about a patient of mine very early in my career, a woman who had 6 older siblings, her mother and her grandmother all had Alzheimer's disease. She was the youngest. She came to me when she was maybe just turned 60 and was very worried because she was having symptoms. She had sleep apnea, didn't know it, took medicines, high anticholinergic, was diabetic, had high blood pressure, high cholesterol, didn't exercise, and she had depression. I said, take care of these things. I just saw her, she's 90,
Oh,
no Alzheimer's disease. The only family member. So just the strength of prevention, okay?
So thank you for the talk. It's great. So physicians are very busy in the office practice. We don't have much time.
Yeah.
And so do you recommend any like tools we can use, screening tools? We are already busy, how we can be very effective in finding out, because it's very common.
Yes,
And so you, as you mentioned, as you point out,
yeah,
and when you already manifest the symptoms, it's already too late. So how we can use, have some tools?
you're a physician.
Yes.
Okay. Let's talk a little offline. Let me just say, this is something we're working at UC, is how can we help our colleagues do this work in a way that works, okay? And I can talk to you about some things, okay?
Second question.
Yeah.
So, these days we treat a lot of patients have cancer. We
Yes.
treat with chemotherapy. We try to minimize or try to avoid cytotoxic chemotherapy, but still we have to give, the chemo brain has become more recognized.
Yes.
So any things we can do?
Yeah. That's the other area that I see patients. What we're understanding is people come to cancer with the same risk factors as they do for neurodegenerative disease. And what we're now looking at are all the issues that impact a person even before chemotherapy, even before they have any treatment, and optimizing it. Sleep issues are number one. So in our research, we found that the number one association of chemo brain, quote unquote, is sleep apnea and disturbed sleep. It's associated also with high body mass index. So now our breast cancer group is going to screen for sleep disorders and have discussions about diet and body mass index.
Lastly,
Okay.
so as we age,
Yes.
so the short-term memories affect more. Why and how we can improve that?
It shouldn't be. Let me just put it that way. If it is, still the major issue is usually sleep related, or medical conditions that are not adequately controlled. I'll give you that answer because when we do see people who have these complaints, we take a deep dive into all the things that might be happening that contribute to that, but it is not considered a normal part of aging.
Okay, thank you very much for your presentation. It was very enjoyable and
Thank you.
informative. My question is, we know that Alzheimer's is caused probably by an oxidative process and inflammation and so forth. If you take things that are, let's say, like vitamin C, extensive amounts of vitamin C, terpenes that are anti-inflammatories and antioxidants and so forth, will that potentially aid in or diminish the possibility or defray maybe the development of Alzheimer's?
So the question was, are taking supplements essentially that lower inflammation helpful? Supplements are complex. Let me just say there are aspects of supplements that are dangerous because we don't know what's in them, and off-the-shelf evaluations have shown they contain things that are toxic. Also, in trials, prospective trials, none of the supplements have yielded any benefits. The association of a particular nutrient with reduced Alzheimer's risk has to do with the fact that nutrient was complexed with food that we ate. And the microbiota, the bacteria in our intestines, have evolved to extract the nutrient from the food, and it's in amounts that can be managed. This bolus, this extra amount that we would swallow in a supplement can't be used and might actually damage the gut microbiome. So at the moment, we don't have anything that is that we should take in a concentrated way. We should get it through food, okay?
I got one more question here, and that is, it might have been 60 Minutes or some other studies there, but they were talking about nuns, specific nuns, okay? And these, as we know, a lot of them live for, into their hundreds and so forth. And many of them don't develop any dementia or Alzheimer's. And so they've been very kind to donate their brains after their death. And they found in many cases they have like half the brains essentially gone, covered with tile, but still they were cognitive. I mean, how do you explain that?
Well, then it goes to this idea that the instruction manuals we come with are all different. And those, the people who have no cognitive symptoms despite the presence of all those diseases had genes that help regenerate connections. They had genes that tended to lower inflammation in the presence of these disorders. And they had high cognitive reserve. The lifestyle factors that created redundancy of connections. And in fact, those individuals even started out with better networks. They know that from the essays that they wrote when they had to enter the convent. They wrote essays. They analyzed the degree of complexity. Those nuns that had the more complex essays are the ones that did not develop dementia, even with the presence of the cognitive, the pathology in their brain. So still possible for all of us.
I know that I want to reduce these anticholinergic medications. I had no idea what they were when you put them up there in the screen. I didn't recognize any of them, but you did mention or allergy medicines.
Yes.
I do take an allergy medicine, loratadine. Should I stay away from those things?
Of all of them, loratadine is not so bad. It's kind of, what else are you taking? I would just ask your doctor to look at all your medicines and say, I heard about this anticholinergic activity that my medicines might have. Can you take a look and make sure that it's not too much? Okay?
I have a question from online.
Yes.
I take gabapentin at bedtime for back pain. Stenosis only bothers this person at night when they sleep, works well. Does that impact this person's sleep quality?
So gabapentin is a little problematic because of its anticholinergic activity too. And it does have an association with increased risk or dementia. On the other hand, if pain is interrupting your sleep, that's bad too. The key thing is minimize the amount of anticholinergic activity. So if that's the only drug you're taking, you're probably okay. But take a look at everything else and make sure that you are keeping that overall anticholinergic activity low.
I want to thank Dr. Schatz. I hope that all of you found this as helpful as I did. It seems so from the questions. I think it's great to know that we have a lot of control over the aging of our brains. So I hope everybody gets a good night's sleep tonight. We are currently putting together a Lunch and Learn series for 2025. If anyone has any suggestions for topics, please let us know. We'd love to incorporate those. And if any of you have a friend or a family member that could benefit from working with Truepoint or commas, please reach out to your advisor for an introduction. We believe that everybody can benefit from working with an advisor, and that's exactly why we created our commas service line. So there would be no barrier to entry because there are no portfolio minimums. I just want to thank all of you for coming today and have a great rest of your day. Thank you.